Today we are going to start chapter 9 and we're going to do lesson 2, prime and composite numbers. So let's look at the definition. The factors of a number help us to determine whether or not a number is prime, composite, or neither. So you'll see over here on this side, I have my own prime number chart, and you should also have your own prime number chart that I sent. So let's look at example 1. Blair is arranging 18 cupcakes on a shelf. Find the factors of 18. Use arrays to find the factors. Well, so this is just like the arrays we were doing with multiplication. So we have one row. And how many columns do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We could have told that from how many cupcakes she has on the shelf, but I wanted to count just to make sure. So in this one, she has 2 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So that's another way we can arrange it. And we can also go 1, 2, 3 by 1, 2, 3, 4, 5, 6. So there are 3 different ways she can arrange these cupcakes. So the factors of 18 are 1, 2, 3, 6, 9, and 18. And all I did was copy these numbers down over here. So that's how we find out our factors. Because 18 has more than 2 factors, it's a composite number. So let's look at these definitions. So a prime number is a whole number with exactly 2 distinct factors, one in itself. So let's look over here at our prime number chart. So it shows us all of these highlighted numbers are our prime numbers. So let's take number 2. So 2, we can't divide that into anything else than 1 times 2. There's nothing else we can multiply to get 2. A composite number is a whole number with more than 2 factors. So the examples they give us are 4, 6, 10, and 20. If we take, for example, 4, you can do 4 times 1 equals 4, and also 2 times 2 equals 4. So because there's multiple ways to multiply it, it's a composite number. And the numbers that are neither prime nor composite is 1. 1's kind of all by itself. And also 0. Those aren't prime or composite. They're just different kinds of numbers. So let's go on to the next page. So Sarah is at the park. She counts 73 kites. Write the factors of 73. Tell whether it's prime, composite, or neither. So let's look at our chart over here. Well, 73 is highlighted, so that must be prime. So we can write that it's a prime number. And what do we know about prime numbers? Well, their factors can only be 1 and itself. So our factors are 1 and 73. On to number 3. Tell whether 1 is prime, composite, or neither. So 1 is just 1 times 1, and since 1 only has 1 distinct factor, it is neither. Remember, 1 is that weird one where it's neither prime nor composite, so we can just remember it's neither. Okay. Let's go on to the guided practice, and for these we can just use our number chart. So 5, well, over here it's highlighted, so that's going to make it prime. 15 is not highlighted, so that's going to be composite, and I'm just going to put a C or a P. So, okay. Number 3 is 21. Well, 21 is not highlighted, so this must be a composite number. Now, what about 31? 31 is highlighted. There's nothing but 1 times 31 that equals 31. So this one's prime. What about 26? 26 isn't highlighted, so it must be composite. And we can also check that because we know it's 1 times 26, or 2 times 13 equals 26. So there are multiple factors, so it must be composite. Let's look at 61. 61 is highlighted, so it must be prime. So because 1 times 61 equals 61, and then there's nothing else. Let's go on to the next page. All right, more of the same. We're going to write whether each number is prime, composite, or neither. Well, 1, we know that's that weird one, so it's going to be neither. Let's look at number 3. 3 is highlighted, so that must be a prime number because only 1 times 3 equals 3. 9, see number 4. 4 has multiple factors. Remember, we can do 2 times 2 and 1 times 4. So this one is composite. 14, let's do this without looking at the chart. We know we can do 1 times 14, but we can also do 2 times 7. So this must be a composite number. We can check by coming over here. Yep, 14 isn't highlighted, so it must be composite. Okay, let's do number 29. 29 is highlighted, so that must be prime. So only 1 times 29 equals 29. 41. Can we think of any factors other than 1 times 41 that equals 41? I can't think of any, so let's check. Yep, it's going to be a prime number. And what about 50? Well, we know there's 1 times 50. We also know we can do 2 times 25 or 5 times 10. So there are multiple ways. So this one must be composite. We can check over here. Yep, it's not highlighted. What about 63? 1 times 63 or 9 times 7. So this one must be composite, and it is. Let's look at 65. Well, we can have 1 times 65, or we know it ends in a 5, so it must be divisible by 5. So let's check over here. Yep, 65 is a composite number. Let's look at 79. So we know it can be 1 times 79, but can we think of anything else? Does it follow our divisibility rules? See, 9 plus 7 is 16. That's not divisible by 3. So this one I'm thinking is prime. Let's check over here. Yep, 79 is prime. Let's look over here, 84. Well, we can do 1 times 84. We can also do 2 times 42, and we could even keep going with that one, but we know there are at least 2 factors, so it must be a composite number. Let's check. Yep, 84. All right, and 97. Well, we can do 1 times 97. I can't think of anything else. We already know 9 plus 7 is 16, and that's not divisible by 3. So I'm going to say this is probably prime. Let's check. Yep, it's highlighted, so it is prime. Okay. Now it wants us to circle the prime numbers and cross out the numbers that are either composite or neither. So I'm going to do this in different colors. So we're going to have our prime numbers be purple. So you can just use your chart. So we're going to circle 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. And what do you notice about these numbers? I notice something right away. All but this number 2 up here, all of these are odd numbers. And why would you think that is? Well, we know that every even number, so 4, 6, 8, 10, 12, they can all be divided by 2 because they're even. So we always know that an even number is probably gonna be a composite number because you can divide it by 2. So let's do this other part. I'll use teal. So we're gonna cross out the numbers that are composite or neither. Well, 1 is neither, then 4, 6, 8, 9. 9 is an odd number, but we also know 3 times 3 equals 9. So that makes it composite. 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, 26, 27. Let's think about 27 because all these other ones in the line are prime. So what makes 27 special? Well, we know 3 times 9 equals 27. So we got to think of our factors that have 3's, and that'll help us there too. 28, 30, 32, 33 is that another one like that? It's 3 times 11. 34, 35, 36, 38, 39, 40, 42, 44, 45, 46, 48, 49, 50. And let's look at 49 because that doesn't have a 3 in it, but it can also be 7 times 7 is 49. So that's that second factor. Okay, on to number 20. Write a prime number that is greater than 50. Let's look at our chart over here. So 50 is right here. We just have to pick any prime number bigger than 50. So I'm going to pick the first one, 53. But you could also say 59, 61, 67, all the way to 113 on this chart. Now we're going to write a composite number that is greater than 70. Well, 70 is over here. It is a composite number. So our next composite number is 72. But you could pick any of these even numbers or any of the numbers that end in 5 all the way up to 120. There's a lot of choices with that. So let's go on to the next page. What prime number is greater than 88 and less than 95? Well, let's look at our chart. 88 is right here and 95 is right here. So what's the only highlighted number in between here? 89. Ken is planting vegetables in his garden. He has 20 seeds. Determine whether 20 is prime or composite number. If it is composite, list all the ways Ken can arrange his seeds in even rows. Well, let's look at our chart over here. 20 isn't highlighted, so it must be composite. And let's look at all the different ways. Well, he can put 1 times 20, or we also know 4 times 5 equals 20. Or we could do 2 times 10 equals 20. So there are 3 different ways he can arrange his seeds. Number 24. Susanna is making a quilt by sewing together pieces of fabric. She has 49 fabric squares. Draw an array to show how she can create a quilt that has the same number of squares in each row and each column. How does the array help you determine whether or not 49 is prime or composite? Well, I don't have the room to draw a diagram over here, but we can look at our multiplication chart and we can see that 7 times 7 equals 49, which would give us an equal row and equal column. We can also look over here and see that 49 isn't highlighted, so it must be composite. Because it has a factor other than 1 and itself, it also has 7. On to number 25. Draw a conclusion. Carrie adds the prime numbers of 3 and 7 and gets the composite number of 10. She states that the sum of any two prime numbers is a composite number. Is Carrie correct? Explain why or why not. Well, what we have to do is find an example of whether or not this is true. I'm going to right away tell you that this is not correct, because that's going to make it a little bit easier. So let's look at our examples. We want to add two prime numbers together and get a composite number. So 2 plus 3 is 5, so that doesn't work. 3 plus 4 is 7, that doesn't work. 5 plus 7, well, that would be 12, so that counts as 1. Yeah, so we can do 5 plus 7 is 12. See her example. She states that the sum of any two prime numbers is a composite number. Well, we already saw that with 2 plus 3 is 5, which is prime. So her rule doesn't always work. What factors do prime numbers and composite numbers have in common? Well, prime numbers always have 1 in common and the number. So 1 times 49, or 1 times 3, or 1 times 59. This is that number that I'm talking about. All right, on to your homework. Patrice is having a tea party. There will be 13 people at the tea party altogether. Can Patrice divide the chairs evenly among more than one table? So this is the example they're giving us, and we can see that no, there's only one way to divide 13 evenly, and that's by 13. So there's only one way, and so it's a prime number. So they give you the definitions up here again, so let's look at our practice. So tell whether each number is prime, composite, or neither. So let's look at our chart. 16 isn't highlighted, so it's composite. We can check because 1 times 16 and also 2 times 8. 37 is highlighted, so that's prime. How about 50? Well, I know 1 times 50, but also 5 times 10 and 2 times 25, so this one must be composite. And if we check, yep, not highlighted. All right, down to 41. Well, there's 1 times 41, but I can't think of any other factors. So, yep, let's check. It is prime. What about 1? We always know 1 is neither. It's neither prime nor composite. What about 81? Well, we know 1 times 81. We also know 9 times 9, so this one must be composite. Let's check. Yep, it's not highlighted. All right, last page. Tell whether each number is prime, composite, or neither. Remember, 0 is just like 1. That's going to be a neither as well. It's 11. Well, 1 times 11 and nothing else, so this one must be prime. 90. Well, it's an even number, so we know it must be composite. Let's look at 75. We have 1 times 75 and then 3 times 25, so that must be composite. Let's check. Yep, 75 is composite. What about 53? Well, we have 1 times 53, but I can't think of anything else. It's an odd number. And 5 plus 3 is 8, which isn't divisible by 9. So let's check. Yep, it is a prime number. What about 23? 1 times 23, but it's an odd number, so let's check. Yep, it's prime. On to number 13. Colby has 16 jars of spices. He wants to arrange them in arrays. What arrays could he use to arrange them? So they're even telling us that there's going to be multiple arrays. So we know we could do 1 times 16, but we could also do 2 times 8, or we could do 4 times 4. And you can draw these out if you need to. Winnie has 7 soccer trophies she wants to display in an array. How many different arrays are possible? Well, we know she can do 1 times 7 because all numbers have those 2 factors. But are there any other ways? Let's look over here. 7 is prime, so there's only 1. Only 1 array is possible. Okay, and we're gonna skip 15 and let's go on to 16. Identify the smallest composite number you can create by multiplying 2 different composite numbers. So let's look at our chart over here. Our 2 smallest composite numbers are 4 and 6. So 4 times 6. So let's figure that out. Be 24. So that's the smallest composite number that we can make. Let's draw a line to match the vocabulary term with its example. So a prime number, let's look at our examples over here. Well, 21 is composite, so we're going to match that here. And 61 is prime. Test practice. Which of the following is a prime number? Well, let's look over at our chart over here. Is 67 a prime number? Yep, it's highlighted. And just to make sure, 63, not highlighted, 65, not highlighted, and 60, not highlighted. So that is the end of lesson 2.